Exercise 7a is where we look at logarithms properly for the first time. Now, you may have seen these in lessons already where we're talking about sometimes having to undo what we would call exponential equations. So an exponential equation would be something like 3 to the x equals 200. Now, you may have seen how we can get rid of these, but it's important to know these then are what we call exponential functions. And they're exponential because the power is the x. So as opposed to say, if it said x cubed, that's different. You can see the power is a number, a normal number. But when you have a power which is an x, that's an exponential function. And we use indices. Well, we've already used indices, I suppose, but we use logarithms to solve these exponential problems. So indices, a little starter, you'll need to pause the video just to work these out and then we'll start again. Okay, so hopefully you have paused the video, hopefully you've got 5 answers, and here are my answers then. So when you times 2 powers, you should remember from GCSE you add them, so that's 5 to the 7. When you times them, you still add them, so it's 2, but minus 2 plus 8 is really like a subtraction, I suppose. It's 2 to the 6. When you divide them, well, it becomes 12, and you should remember you subtract the powers. So you don't divide the powers, you subtract them. So 6, take away the 3, is actually 3. Notice, by the way, I don't want these as, I don't care what 12 cubed is. 2 to the 6, for instance, I know 64, but who cares? What I want is the power. What do you do then when you have a power raised to a power? Well, you should know you times them. So this is 7 to the 12. And this is just a bit of simplification, really. First of all, I don't like the numbers. 15 times 2 is 30, divided by 3 is 10. So I've dealt with the numbers. Now what about the a's? That's like an a to the 1 times a cubed is, you add the powers, that's 4. But I've got a squared on the bottom, so I take that away. I think I've got a squared left over. And do the same with the b's, b to the 4 times b to the 2, that's b to the 6, all divided by b to the 6, and anything divided by itself is 1, well, nearly anything. So I think that's the answer. So if I got these answers here, 10a squared, last one, good. So on that basis, suppose we want to solve this equation, 10 to the x is 75. Then we can use our calculator to do it. You can type in now 10 to the power of something equals 75. If you're not sure how to do the powers on this calculator, you're looking for the button, which literally looks like that, and it's about that one there, I think. And you're looking for that, and you type in 10 to the power of something. Well, I don't know. I know 10 squared is 100, so it's got to be less than that. I'm going to say 1.5. And I press equals, so I'm going to do that now. 10 to the power of 1.5 equals, and I get 31 and a bit. So this isn't very close. So 31.6ish, I'm going to say. See if you can get any better than that. So hopefully you've done a few. Don't know how many you've done. You might have done. I'm going to have one more go, and then I'll ping up the answer. I'm going to try 1.7. Let's try 10 to the power of 1.7. 50.11. I'm still too low. It's obviously bigger than 50.1. Oh, I said I'd have one more go. I'm going to actually have two, and that one more go. I don't know what it is. I haven't tried. There's a quick way of doing this, of course, and that's what I need to show you. It's still too low. So it's bigger than 1.8. 63.1 if I do that. So when I've done it, I've got 1.875. So I was close. So that basically tells me that 10 to the 1.875 is about equal to 75. It's not exact. I'm going to try it since I didn't get it before. 10 to the power of 1.875 equals, and it actually comes up when you do this, it's actually equal to 74.9894 ... So this is, even this isn't exact, but it's to 3 decimal places. It looks as if it's correct. We need a better way of doing it, and it's the logarithm button that allows me to do it. And let's go back to this 10 to the x equals 75. This is what we are going to try to do. We basically think of this 10 to the x moving over to the other side. But when it moves over, you need to learn the opposite, the inverse of this exponential button is what we're going to call the logarithmic button. And that's what we've got to type in. So on my calculator, I've got this thing here that says log. It doesn't actually say to the base 10. Lots of calculators have these, but this particular calculator that we're using, you've got to tell it what base power you want. So you've actually got to slide a 10 in there. Now this log button that I'm using is next to it. It's this button here. So you should be able to type in the log to the base 10 of 75 and press equals. And again, that should be a more accurate version of what we just found out. The 1.875 bit, 1.87506. Now obviously that's more accurate than anybody really needs. But it just gives you the idea that it goes straight to the answer. It's always nice to get the answer straight away. Just learning this button is always useful. But notice what we did then. We had a 10 to the power of something, and we moved it over, and it became the log to the base 10. So I want you to think of these as exponentials are the inverse of these logarithms. And I've written that down here. We can consider logarithms as being the opposite, or technically the inverse, of powers or exponentials. Really, again, I've written powers, but really I want us to think of these as exponentials. So say I get this question, 10 to the x is 52. I move the 10 to the x over to the other side. It becomes x equals the log to the base 10 of 52. And when you see it like that, you think, that's easy enough. The 10 to the x moves over, it becomes a log. So let's just do that. I'm going to do it now. Log button, base 10, little 10 at the bottom, 52 equals, what's it? It's 1.71-ish. And it says 3 significant figures here. So I'm going to write x equals 1.72, I think. 1.72, good. So in general then, this is saying that if you've got 10 to the power of x, you move it over, and it becomes x is log to the base 10 of b. So this general idea that you can move the exponential to the other side, and it becomes a logarithm. What happens if you get 2 to the x is 54? It's exactly the same thing. X moves, the 2 to the x moves over, leaving me x on this side, and we get a log. But now, obviously, because it says 2, it's going to be base 2 of 54. So we're going to type that in. I want you to do the same as I'm typing this in. So what was it? Log to the base 2 of 54. And again, reminder, this button is this one here. That's what I've just typed. That button there. And that says 5.7. Well, how many decimal places? It doesn't tell me how many decimal places. I reckon 5.75 to 2 decimal places. And this is the right answer. That's a good sign. Other logarithms also exist. So in general, if you have a to the x equals b, this a to the x moves over, and notice what it becomes. It becomes a log to the base a. It's really nice. It's a good, simple way of thinking of this as the inverse. The logarithm is the inverse of that exponential. And move the exponential over, it becomes a logarithm. So make sure you make good notes on that. And as I say, the calculators are great on the Casios. It's really good. On some of the older calculators, you haven't got that log to the base n button. So this one does. So anyway, we've got to rewrite these, and you can do these in the same way. It hasn't got the x's, but it's the same trick. So rewriting this, if I move this over, notice that the power stays, and it becomes a log to the base 4 of 64. And the great thing about this is you can type that into your calculator. So type in log to the base 4 of 64, and with any luck it will give you the first bit, which is 3. Yep, it does. So what does this bit 1 do? I move this over to the other side, and when I move that 9 over to the other side, I'm left with 3 over 2. But because it's an exponential, it becomes log to the base 9 of 27. So again, type that in, log to the base 9 of 27 equals, and it says 3 over 2. So it works really well. Got a couple for you to do there. Are these the other way around? Yeah, they are, aren't they? These look like we've got a log and we want the exponentials. So if I move that over, basically it becomes 81. And the critical thing is that's the base number, 3 to the 4. If you type 3 to 4 in your calculator, it will give you 81. This one, move the log onto the other side, gives me 2 equals, the base number is 4 to the half. And 4 to the half is really the square root of 4, and that is 2, so it kind of works. So a little exercise for you to do. You might want to pause the video and then turn it back on in a bit. So pause now and see if you can do these 4 rewrites. Hopefully you've done those 4. You've rewritten the first 2 as logarithms and the second 2 as exponentials, and these were my answers when I did them. So hopefully you've got that, and I think we're getting close to it now. Maybe a couple more of these to simplify. Now when you simplify a course, now you're going to have to tidy these up. So we're using our laws of logarithms. So let's just remember, when it says base 2 here, I want you to try to write this number. If they tell you to simplify, I want you to try to write this number as 2 to the power of something. If we can do that, then we can do something here. And I think we can, because I know that 16 is 2 to the power of 4. If you're not convinced, that means 2 times 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16. Yeah, it works. So this is really equal to log to the base 2 of 2 to the 4. And what I want you to suss is, when you get log to the base 2 of 2 to the something, well, I've said these are kind of inverses of each other, so these effectively cancel out, and the answer is 4. That makes it a lot easier. This one, so this says log to the base 9 of a third. Now I need to write a third as 9 to the something. If I can work out what that is, then I'm sorted. Immediately I think, hang on a bit, 9, if I square root 9 I get 3. And I should know that, therefore that's 9 to the half, because square root is really a power to the half. So if I know that information, I also notice it's on the bottom. So I'm going to suggest we should know that a third is really 9 to the minus. You should know that if you get a power on the bottom, it's a negative power. So that's really 9 to the minus a half. And if you're not convinced, type into your calculator using that x to the n button I was telling you about before, the x like that. You can type in 9 to the negative half and it should come up with a third. But anyway, coming back to this, that tells me that really I've got 9 log of 9 to the base 9. Oh, what was it? 9 to the minus a half. And the great thing is, when you get that and that cancels, and my answer has got to be minus a half. See if you can do some of those. Minus a half and 4. Good. We've got 4 for you to do. See if you can do these 4. Pause the video and see if you can do them. Okay, so what would I suggest? Well, I'd think of 100 as 10 squared. So therefore, the 10s cancel. I think the answer is 2. 64, I'd think of 64 as 64 cubes. Sorry, 4 cubed. That's nearly rubbish, that. So in which case then the log 4 and the 4 cancel and I get 3. Root 5 I can think as 5 to the half. So the log to base 5 of 5 to the half I think is just a half. You can see the powers becomes very important here. This one's probably the hardest. You've got to write an eighth. First thing I noticed 2 cubed is 8. 2 times 2 times 2. But I've got 1 over 8. So that must be 2 to the minus 3 because it's on the bottom is an 8. So this really is, that guy I can cross out and write 2 to the minus 3. So that cancels that, and I think my answer is minus 3. I've got 2, and I've got 3, and I've got a half, and I've got minus 3. That we're out of time. We've done all the stuff for the lesson. So hopefully that we'll go through all these questions in class. I don't know why I've written do these but not do the others. And we'll do all of that exercise 7A in class, and hopefully that makes sense. We can do them, and then we can go on to what are called laws of logarithms, which we'll need as well. All the best.